in a teacher's pet in my life. I'm just not a very good student.
Oh, wow.
Yeah.
That sounds like a great life lesson.
It is a good life lesson. I feel like I could have accomplished more in my academic life if I had just been more appeasing. I was too prideful, I think. I was too individualistic. I was like, didn't want to follow trends, and I just wanted to do my own thing. Mm, like not showing up to class a lot. Yeah, I ditched a lot of school when I was in high school.
It's a Benjamin told me.
I'm not sure. I don't know. I assume so. They called home. Well, it's a lesson for you guys. I also don't think I got good rec letters because I wasn't very nice to my teachers. I wasn't mean. I was just not like friendly or I didn't suck up.
So Mr. Nice doing me a good, right?
Yeah.
Yeah, I think we have yeah, I don't hate you, so. Okay, so a simple graph is r equals 5. That's a circle, right?
Yeah.
As we learned from the homework. Because r equals 5 is all the points that have a radius of 5 away from the origin, so that's obviously a circle. Okay? Everybody have it written down? Another simple graph is theta equals pi over 3. That's all the points that are direction pi over 3 from the x-axis, right? And so that's going to be a straight line. That's 60 degrees away from the x-axis. We also saw that on the homework. So a good life lesson is that sometimes in life, you're going to have to do some things that you don't want to do in order to be successful. And that's okay. It's okay to, suck up to people. It's okay to follow trends. It's okay to be normal. Okay.
I don't think you can say anything.
Sometimes you just have to play the game, and that's just how life works. So you want to do it in an honest way, but it's okay to do those things. Let's do a more tricky one. Let's do r equals 3 sine theta. Okay, so if we were to graph this as a Cartesian plane, you guys know what this looks like, right? We remember these things? Sinusoids.
Wow.
But actually, when we graph this in the polar plane, this is actually also a circle.
Okay, right.
Oh.
Oh, no.
So it's circle radius.
No,
Oh.
radius 3/2.
We have.
Yeah. Okay, so let me show that to you. And the best way to graph is always by starting with a table, and we're going to try different values of theta and then plug them in. Okay, so we can start with theta equals 0. What does that give us for r?
0.
How about pi over 6?
2.
3.
3/2.
Hmm.
Pi over 4?
2 or 3 squared 2 over 2.
Pi over 3?
Uh,
I'm just going to do it myself. It takes too long if I wait for you guys. No offense. Okay, so I've gone from 0 all the way to pi over 2, and we'll see what kind of shape that makes. So let's now graph this in the polar plane, okay? So not Cartesian, but rather polar. 0, 0, that's just the origin, right? Because the radius is 0. So we start off here. How about where is 3 comma pi over 2? Where is that?
You.
It's on the y-axis, right? Three.
Yeah, it's right here. And that's going to be 3 units away from that first point. Okay, let's do pi over 6 comma 3 over 2. That is going to be somewhere in this direction, right? Pi over 6. Except now it's going to be 1.5 units away. And let me estimate how much that is. Maybe that's like here. Okay. This is quite intricate. Then the next one, pi over 4 comma 3 root 2 over 2. Anybody know how much that is? It's about 2.1, right?
Yeah.
Yeah,
It's kind of my top.
yeah.
So that's right here. You agree? That's like pi over 4, and it's about 2.1 units away. And then the next one, pi over 3 comma, sorry, 3 root 3 over 2 comma pi over 3. What is the, how big is 3 root 3 over 2? No,
It would be like 2.3, right?
no, it's more like 2.5. And so that would be around here. All right? Maybe a little bigger. And as you can see, that forms a circle, right? If we were to trace these out, that would be, shoot. And then if you were to go ahead and do the other ones, if you were to go ahead and continue with the other side, you would get that.
I know, I don't wanna say.
All right, let me do another point. Because we're actually not done graphing, right? We've only gone up to pi so far. How about between pi and 2 pi? So let's plot some other points as well. Where would 5 pi over 4 be? What r is theta equals 5 pi over 4?
Negative square, or negative 3 square root 2 over 2.
Yes. Now where is that on the circle?
Third quadrant.
No, first quadrant. Because r is negative, right?
Yeah.
So the direction is this way, but r is negative. So that point is actually here.
Mhm.
Okay. How about theta equals 3 pi over 2? What is r?
-3.
Negative 3. Where is that?
Y.
Now we're back here, right? Because we have the direction 3 pi over 2, but r is negative. So that's going to get us back to here. And so actually, when we do the third and fourth quadrants, the circle is going to be double traced. Okay, so as theta goes from pi to 2 pi, r is negative, so the circle actually gets traced a second time. And so this is the final graph. Make sense?
What? No, first, second.
And so here's a general rule that you can remember. Anytime you have r equals a sine theta or r equals a cosine theta, this is going to be a circle touching the origin. Right? And the best way to figure out which direction it's facing is by plugging in a few points. Really, all you need is one. So let me do an example of how I would do this quickly. Let's say I had r equals -2 cosine theta. I know it's a circle touching the origin, and all I need to do to figure out which direction it's facing is just plug in a single point. And I'm going to plug in theta equals pi over, I'm going to do theta equals pi. I'll just do theta equals 0. That's all I need. I'll plug in theta equals 0. Cosine 0 is 1. And so r is equal to -2. Now, where's that on the graph? Did you guys do the homework?
Oh. Oh, yeah.
Where is -2 comma 0?
Oh, so it's gonna be on the x-axis and on the left.
Yeah, it's here. It's here because the direction is theta equals 0, but r is negative. Okay? I feel like you guys didn't do the homework. Yes?
Ours is married to this line.
If it's negative, oh.
Cosine 0 is 1. Okay? So because I know it's a circle touching the origin, I know that this must be the circle, right? Make sense? So really, once you know the rule, you just need to plot one point to determine the direction, and you're pretty much set.
But how do you know it goes that way, not like to the left or something?
Yeah, touching the origin. It's always going to be tangent to the origin, actually. That's a better way of saying it. Any questions? So that's an important rule to know. And in general, the best points to plug in are always going to be theta equals 0, pi over 2, pi, or 3 pi over 2. The reason is because that maximizes or minimizes sine and cosine, right? For these angles, sine and cosine are always going to be either -1, 0, or 1. And so those are the easiest to plot, and they also tell you the most about the graph. Okay, so for example, for 1a, you have sine theta, right? So you're probably going to want to plug in r equals pi over 2, because sine pi over 2 is 1. And so you know that you're going to have a maximum r at that point. Luna, make sure you're paying attention. Don't think so. Okay, I'm going to continue because today's lecture is quite challenging. Yeah. I'm not going to collect the classwork, okay? Let's continue. Let us talk about equations of the form r equals a plus b, a plus or minus b sine theta, and a plus or minus b cosine theta. Okay? So these look very similar, right? All we're doing is adding a constant. However, the graphs are very different. And these are a class of curves known as limacents.
Limas?
More French. Limacents. You guys take French? Anybody? Yeah, limacent. And the shape of the limacent curve will depend on the ratio of A and B. Right? You guys, I don't even know French, but I know they have this thing, right?
Yeah.
Okay, so how do we know what the shape is? I'll just tell you the rules right now. If A over B is less than 1, then we have a looped limacent. Looped limacent. And the shape looks like this.
Oh, what's going
If A over B equals 1, we have what is called a cardioid, which comes from the word heart because it looks like a heart. It can also be called a cusped limacent. And this is what the graph looks like for this one. Instead of a loop, it has a cusp. So the loop kind of degenerates. Degenerates. Can't say that right.
Oh, so that's a graph with weird shapes. Oh, the hearts.
And then if A over B is greater than 1 but less than 2, we have a dimpled limacent. This needs to be memorized, by the way.
You didn't know the teams?
No, you need to know the shapes. But the names help you know the shapes, right? A dimpled limaçon, the loop, you can kind of imagine the loop kind of gradually pushing outwards, and it becomes a dimple instead. To help you draw it, it's helpful to draw the dimple first, and then make the rest into an apple shape. And then finally, if A over B is greater than or equal to 2, then we have a convex limaçon. It's convex because the dimple disappears. And you guys know what convex means, right?
Oh.
Yes.
You guys learned convex polygons? Concave versus convex polygons? It's like they don't even teach you anything here. I didn't say that. 0?
Yeah.
If A is 0, then we have a circle, right? We have what we previously just did. And so a convex limaçon, then you just have R equals A, which is also a circle, right?
Copy on the
Right? You guys see how the dimple disappears, and so it's now convex. It's not an oval. It's a limaçon. It's just not an oval. It's not symmetrical. It doesn't have fourfold symmetry. Twofold symmetry. Do we all have this copied down? I'm moving on.
Picture.
Wait,
Yes.
did I take a photo? You're not looking. Yo, it's not, no, that.
Okay.
No, man. What's your name?
5, 4, 3, 2, 1. Yeah, you're not supposed to have devices out. I don't know why you guys are taking photos. So let's do an example.
No. Dang it.
Let's do an example. Let's say we have let's do a looped limaçon, right? So A is less than B for this one. Maybe we have 2 minus 3 sine theta. Right? This is looped, right? Because A over B equals 2 over 3, which is less than 1. So okay, to plot it, we first need to make a table. So let's have R and theta. I'm going to make theta on the right to make it more simple, obvious. So, and then we're going to plug in 4 points. You always need these 4 points at minimum. We need 0, we need pi over 2, pi, and 3 pi over 2. Okay, so just make sure you have those 4 points and then plug it in to find R. I'm not going to wait for you guys to answer it because that would take too long. It'll be 2, -1, 2, and 5. Agreed?
Oh.
Yes.
And then when we graph that, you guys need to be very comfortable with polar coordinates at this point, which is why you needed to do the homework. So the first point is 2, 0, right? Where is that? That is going to be right here. We're going in the direction 0 out 2 units. How about -1, pi over 2? Where is that?
It's below on the y.
Yeah, negative y-axis. -1, pi over 2 is right here. Agreed? And then 2, pi is right here. And then 5, 3 pi over 2 is here. Okay? And this is a looped limaçon, right? And the loop has to pass through the origin. Why does it have to pass through the origin? Well, when theta goes from 0 to pi over 2, R has to go from 2 to -1. And so therefore R has to pass through 0, which means that the graph has to pass through the origin between theta equals 0 and pi over 2. And theta equals 0 is here, and theta equals pi over 2 is here. So to connect those 2 points, we need to loop through the origin. And so the first segment, I'm actually going to color code it. I have a new idea. I'm going to color code it to make the graph clear. Let's see if this works. Okay, so I'm going to do the 0 to pi over 2 segment in blue. That is right here. I'll do the next segment in green, pi over 2 to pi.
The polar graph.
The next segment in purple. Last one in orange.
Oh, you know what?
Make sense?
Why does it go more direct? Why don't you just make the lines? Direct, like straight lines.
It would be wrong. You would see if you plugged in more points. Any questions? I'm moving on. No application. Any questions? I've never used this since pre-calc. Haven't done this in 10 years. As I've said before, sometimes math is just about interesting things that have no application. And that's okay. Maybe they were interested in more things that are just not useful. And that's okay. Not everything that you study has to be useful. You need to get that out of your mind. Sometimes learning is just about joy. Yes. Just because you don't enjoy it doesn't mean it's not good. Okay. Shh. Let's do a cardioid. This is a cardioid because A equals B now, right? So A over B equals 1. Let's plug in our 4 points. Shh. 0, pi over 2, pi, and 3 pi over 2. Anybody have 4 numbers for R?
Yes, I do.
What are they?
So a 0 would be a pi. For 0, it would
It'd be
be
6.
6.
6.
Cosine 0 is 1.
And then it's 3.
No, I'll do
And
it.
then it's 0.
It's okay, it's okay. Let's move on.
What did you take?
It's fine.
Let me continue. So 6 comma 0, that's on the positive x-axis, right?
Reading my.
Okay, it's okay, good. Okay, so 6 comma 0 is there. 3 comma pi over 2 is here. Where is 0 comma pi? It's at the origin. And then where is 3 comma pi over 2? That's right here. All right. And so for this one, now this cusp here is at the origin, so you know it's a cardioid. And so if you were to draw this out, it would look like this. That's not very good. It's important to make sure it's a cusp and not a corner. So this is a cusp. It's very sharp, right? A corner is like that. So a cusp is different from a corner. So that's wrong. This is correct. If your drawing is not good, I will take off points. This class is about excellence and not mediocrity, right?
Wait, that's a really good technique.
Alright, next person to draw the concept of custom.
Mine, that's it, I'm not taking max. I mean, taxes and buy a house instead of.
Yeah, we should be like the dog taxes.
Any questions?
Well, no, buy a house.
So make sure you have a cusp.
That looks like a. That's a
No, it's a cusp.
Please.
Well, now you know that this is acceptable. Yes, the lines need to meet. They don't just touch, they meet. Let's do a dimple. Dimpled limaçon. Let's do a dimpled limaçon. Let's say 5 plus 4 cosine theta. Okay, why do we know that this is dimpled? That's because A over B is 5/4, which is greater than 1 but less than 2. Okay, so let's plug in our coordinates. 4 values of theta, 0, pi over 2, pi, and 3 pi over 2. I'll just not ask you guys. This is 9, this is 5, this is 1, and this is 5. Okay, you guys should be able to do that fast as well. So do some practice. Okay, so 9 comma 0 is right here. 5 comma 5 pi over 2 is here. 1 comma pi is here. And then 5 comma 3 pi over 2 is here. Okay, so you guys can kind of see the loop evolves into a cusp, which evolves into a dimple, right? You see that progression?
Yes.
So how do you draw a dimpled limaçon well? You should start by drawing the dimple. Okay, so draw the dimple first. Make this little U-shaped thing here. And then draw the other part and then just connect the dots. Okay, so this one looks like an apple. Make sure that this side is also a straight line or, you know, a nice round curve. A lot of people draw it like this, and that's not right. This side is supposed to be very round, almost circular. And then you just connect the dots. Okay, you guys took art class when you were little, right?
What?
So that would be a nice 10 out of 10 dimpled limaçon. Any questions? Any questions? Okay, I'm going to continue on to Rose curves. So there are only 3 types of curves, okay? One is the circle, one is a limaçon, and the third is a Rose curve, and then we'll stop there. There are others, but we'll not cover them. So there's also a curve called a lemniscate, but we're not doing that. You can read the textbook for that. So Rose curves are the class of curves that cover the categories that cover the equations a sine n theta and a cosine n theta. So now we're going to have an integer constant that's in front of the theta. If you do not have an integer constant, or I should say, if you don't have a rational constant, then you're going to have an infinite number of petals in your Rose curve. However, if you have a integer constant n, then there's a simple rule, which is that if n is odd, then you have n petals or lobes. And if n is even, then you have 2 n petals. Okay? So just remember this rule. It's quite simple. But people get it mixed up. They think that odd means times 2n and even is n, but it's not the case. Odd is n and even is 2n. Okay, let's do a simple example, perhaps from the classwork, just as a matter of generosity to you guys. So let's do 4 sine 2 theta. Okay, so to graph this well, we have to plug in a lot more than 4 points, unfortunately. Not too many more, just 8. So why do we have to plug in 8 points? That's because we're we're primarily interested in the theta values such that 2 theta equals 0, pi over 2, pi and 3 pi over 2. Make sense? So we're trying to get 2 theta to equal 0, pi over 2, and 3 pi over 2. And so in order for 2 theta to equal those values, theta, we're going to have to do multiples of pi over 4 instead. Make sense? So that means we have to go through all 8 values. Got it? And if we had 3 theta, that would mean we would have to do multiples of pi over 6, etc. Got it? And so theta, I'm going to iterate over 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4. We're not actually going to do all of them, but we'll get the pattern first. All right, so what if we plugged in theta equals 0? We're going to get r equals 0. If we plug in theta equals pi over 4, then that means 2 theta equals pi over 2, and then sine pi over 2 is 1. And so r will be 4 in that case. How about for theta equals pi over 2? What is r? Zero? Okay. How about 3 pi over 4?
Maybe 5 or 6.
Oh, 2 theta.
Yes, -4.
Oh, my God.
I'll stop there and let's first plot these points and see where they end up. All right, so the first point is r0, 0, r0, theta 0. So that's at the origin, correct? Where's the next point? 4 comma pi over 4 is here, right? And then 0 comma pi over 2, we are once again back at the origin. So maybe I can do the colors again. So going from 0 to pi over 4, I'm going to have half of the petal here. And then going from pi over 4 to pi over 2, I'm going to return back to the origin like that.
Oh, is that a clover?
Sure, I don't know. And then if we go from pi over 2 to 3 pi over 4, so where is -4 comma 3 pi over 4? Which quadrant?
The second. No, 4.
Fourth, thank you. After 3 tries, we got there. Okay. Now we're going to cover this part of the petal. So theta is going between pi over 2 and 3 pi over 4, right? So theta goes there. However, r is negative.
0.
Shh. And then that means that the graph is actually going to trace this way. Because theta is going this way, but r is negative. So actually, in reality, the point goes that way. Make sense? And then this pattern is just going to continue onwards. I'll do the rest in purple. And the rest of the graph will look like this. Okay. And indeed, for 2 theta, we have 4 petals, right? All right, so in reality, when you're doing these questions, all you need to do is figure out where 1 petal is, then figure out the number of petals, and then just evenly space the petals according to the first one that you found. Very similar to what we did for Euler's theorem, right?
Oh,
so
yeah.
What is a clover?
Like, it has a graph board. One table.
Yes, you do 4 petals for 2n.
But if it's like, you have like 12 petals, and you can still just graph 4 points, right? And then figure it out.
For 12 petals, you only need to graph 1 point and just evenly space the rest of the 12. I would not give you 12 petals though. It's too hard to draw. Okay, let me continue.
Yeah.
Let me do the 3 petals one. It's not going to be the same as the classwork, so don't just copy it. Okay, so let me show you guys how I would do it myself quickly. Okay, so n is 3, right? So how many petals are there? Thank you, 3 petals. And then I'm going to just graph 1 point. Guys, please be quiet. I'm very concerned for your grades. Yes, so pay attention. So I'm going to first plot 1 point. And which point do I choose? I want to choose a point that makes sine 3 theta equal to 1, right? Because that will tell me where a petal is. Does that make sense?
Yeah.
If sine is equal to 0, that doesn't give me any information. And therefore, I want 3 theta to equal pi over 2. Make sense? Because that will make sine equal 1. And then my next point would be to divide both sides by 3. And so the thing I want to plug in is actually theta equals pi over 6. Make sense? So I don't want to just plug in any random thing. I want to plug in something useful. Got it? You can also plug in something that makes sine equal to -1. That also works. That also gives you a petal, right? But sine has to equal 1 to tell you where a petal is. Okay, then if I plug in theta equals pi over 6, sine pi over 2 is 1, so I get r equals 5. So now I can graph it because I know where one of the petals are. So I know that the outside of the petal must be at pi over 6, which is right here. And so if I go, I know 3 petals, they must be spaced by 120 degrees, right? And so I know the next petal has to be here, and the last petal has to be here. And so if I connect all the dots, what will this look like? 360 divided by 3. Okay. Is that correct? It's not very good. It's actually going to be tangent to the x-axis, so I didn't draw that right. All right. Try some classworks.
The last one, you gotta be more than it's all.
Doesn't matter.
Okay.
Mr. Knight, could you please scroll up to the rules above the end? I don't want to be here. Yeah.
Hey, that's